Hi everyone, today I want to go over a simple mass spring system and why we're actually considering gravity, even though a lot of the physics lectures and engineering homework, physics homework, things like that, it looks like we're actually not taking into gravity, but actually we are, and that's what I want to go over today. And I'm going to prove to you guys that we're actually taking it into account, but it gets canceled out, and you'll see why. So this simple system, we have a mass, a spring, and it's attached to a ceiling, and we have three different cases. We have case A, B, and C, and in case A, we're going to say that there's no gravity, no applied force, so no motion, and it's just going to be there. But on our B case, we're going to say, okay, we're going to turn on gravity, but we're still not going to apply a force. And when that happens, the gravity is going to push it down, right? It's going to attract it. And then we also have the spring applying a force upwards. And this displacement due to gravity, we're going to call Y gravity. Right there, I highlighted that in blue. Then our case C, we're going to say we have gravity, and we're going to apply a little bit of force to it. We're going to pull it down, and that applied force is going to create a displacement called Y spring in this case. When we do some of the forces, we usually do sum of the forces equals MA, and we're going to say the positive direction is upwards, so we have negative mass times acceleration of the system equals force of the spring, we're going to call that Fs, minus mg, which is going to pull it downwards. But we also need to understand that force of the spring is going to be K multiplied by Y gravity plus the Y spring, the displacement due to gravity and the displacement due to the force. But in our case, we're going to say, in a lot of textbook cases, we're going to say the Y spring equals Y. When we put that into here, we're going to simplify it. We're going to say negative my dot dot, because that's a lot of what the textbook does, where y dot dot is the acceleration of the system. We have k y gravity plus y minus mg. Now this is where it gets a little bit interesting. We say that k y gravity equals mg because it was a spring force that created a equilibrium state, which is right here, before we applied a force. So what that means is that when we turned on gravity, this spring displaced that much in our case, and gravity is pulling it down, but it's not in motion anymore. We created an equilibrium state before it applied a force. So when you take it slow, when you activate gravity, it's going to go down and it's just going to stay there. And so this spring has a constant force, and the acceleration due to gravity is going to also push it down. And that's where this one comes from. So ky gravity equals mg, and all we're going to do is we're going to substitute this part with this, and we're going to notice that boom, mg minus mg, those two are going to cancel, and now we're left with mass times the second derivative of our y equals negative ky. I hope you guys enjoyed this video, and I hope it shows that we are actually taking into gravity when we're doing simple systems like mass spring or mass spring damper systems. Well, until next time, thank you.